Welcome to The Explainer. So glad you're joining us today because we've got an absolutely fascinating topic lined up. Right out of the gate, our goal is to completely shatter an everyday assumption that pretty much all of us make. The idea that the ground beneath our feet is just this permanent, rigid, totally reliable structure. I mean, we tend to blindly trust the ground, right? But today, we're going to look at why that trust might be, well, slightly misplaced when extreme physics get involved. Think about it. Have you ever been driving on one of those blistering hot summer days and noticed deep, wavy ruts carved right into the asphalt? It almost looks like the road was made of Play-Doh. It's an incredible paradox, really. To a human, just walking down the street, a paved road feels exactly like solid rock. But to a loaded 40-ton truck, that exact same asphalt acts way more like a viscous liquid, especially when temperatures spike and axle loads are pushing right up against their absolute legal limits. Section 1. The illusion of solid ground and the invisible traps hiding right beneath us. Section 2. Distribution defeats total weight. It's all about spreading the load. Okay, so to truly understand this, we need to clear up a major misconception right off the bat. When engineers are figuring out how to protect our roads, they actually care way more about weight distribution than just the sheer total weight of a vehicle. Imagine you're moving a really, really heavy cabinet. If you drop it on a soft lawn and it's resting on four narrow, pointed legs, those legs are going to sink straight down into the dirt under all that concentrated pressure. But if you take that exact same heavy cabinet and put it on a wide, flat base, the grass holds its shape and stays perfectly intact. Spreading the load is literally the ultimate secret to protecting whatever soft surface is underneath. Section 3. How lazy axles save roads. Let's talk about protecting our pavement. So what's the actual engineering fix here? Enter the lazy axle. Sometimes people call it a lift axle. It is simply an extra truck axle that can be lowered down directly onto the pavement to increase the vehicle's contact area. By spreading out that load, the road stays totally intact, which completely stops that hot asphalt from behaving like a destructive, melting liquid. Let's picture how this actually plays out in the real world. Say an empty truck is just cruising along using only 2 or 3 of its axles, which is totally fine. It's pretty light right now. But then it loads up. The exact second that truck takes on 20 tons of gravel, the pressure pushing down on those few wheels becomes absolutely critical. The asphalt is literally on the verge of deforming. So the system kicks in. That extra axle drops to the ground, instantly boosting the surface contact area and perfectly spreading out all that sudden weight. Now, the genius part is that the driver doesn't have to hop out on the side of the highway and manually crank these heavy wheels down. This brilliant weight distribution is handled entirely automatically by what's called pneumatic logic. Basically, air springs force the axle down to the road the moment that massive weight hits, and then a separate lifting bellows pulls it right back up when the truck empties out. It automatically adapts the truck to the physics of the road in real time. It's so cool. Section 4. The problem with natural soil. Let's dig into those hidden voids. Let's pivot away from asphalt for a second and look at what is happening in the natural ground before a road is even built. Here's the thing. Natural soil isn't solid at all. In its natural, untouched state, it is absolutely full of tiny voids. You've got these hidden pockets of air trapped right between the earth and the sand particles. And when heavy traffic inevitably rolls over it, those unstable particles shift around. This creates a massive, massive headache for construction crews trying to build anything permanent. Because think about it, if you just roll up and pour hot asphalt right over that raw, natural ground, the weight of everyday traffic is eventually going to squeeze those particles together. The trapped air will escape, the ground will settle, and boom, you end up with severely cracked surfaces and totally ruined foundations long after the builders have packed up and gone home. Section 5. Controlled vibration. It's time to start compacting the earth. So how do engineers actually fix soft soil? Well, just slapping a heavier static roller on top of the dirt won't cut it, because simple static weight only compacts the very top layer. To reach the deep zones, you need serious energy. And this brings us to our hidden engineering superpower, the eccentric shaft. Hidden away inside the drum of a road roller, this shaft contains unbalanced masses, designed specifically to generate deep-reaching energy. This is the actual engine of compaction that lets us tame the deep earth. Let's walk through exactly how violent and high-speed this gets. First, a hydraulic motor whips that unbalanced shaft up to extremely high speeds. As it spins, that shaft generates powerful centrifugal forces, which then produces literally thousands of intense physical vibrations every single minute, driving straight down into the earth. And the result? Those soil particles literally lift up, shift around, and forcefully rearrange themselves into a much tighter, incredibly dense configuration. Section 6. Respecting the laws of physics. The vital role of the dissipation of energy. You see, taming the Earth isn't just about throwing weight around. It is ultimately about the controlled dissipation of energy. It's a remarkably high-stakes game of balance. If a 40-ton concrete mixer gets even a little too close to the edge of an unreinforced excavation pit, the underlying soil physics can fail in a split second. Under that kind of localized, massive load, the ground simply gives way, entirely swallowing the machine straight into the pit. No warning, just gravity taking over. Which really brings home a powerful quote from our source material. Exact calculations and respect for the laws of nature. Working in this space and overcoming soft ground relies so much on brilliant human ingenuity, but it demands an immense, completely uncompromising respect for physical limits. We have to work seamlessly with the laws of physics, because, let's face it, we definitely can't break them. To wrap up our explainer today, I want to leave you with something to chew on. Think back to that paradox we started with. Have you ever seen a road or a sidewalk melt or deform under the blazing sun? The next time you step outside or see a massive rig barreling down the highway, think about the immense, hidden forces at play right under their tires. Hopefully, you'll look at the seemingly solid ground beneath your feet in a completely new way. Thanks so much for joining us, and hey, keep questioning the world around you.